Hello class, welcome to Unit 2, Video 1. Today we're going to go ahead and look at relations, functions, and linear equations. The learning target for today is that you will be able to identify parts of relations, including the domain, the range, the x-intercept, the y-intercept, and what makes a relation a function. Okay, so let's go ahead and look at a table. Okay, the table shows average and maximum lifetimes for some animals. Okay, represent this data as ordered pairs, with average lifetime being the x value and maximum lifetime being the y value. Okay. So looking at it, they're saying that average lifetime is the x values, and the max lifetime is the y values. So they're saying write this data as ordered pairs. So an ordered pair, remember, is just listed as your x and then your y. Okay, so let's do this. So we would have the ordered pair 12, 12, and 28 for the cat. For the cow, you'd have 15, 30. Okay, the next ordered pair for the deer would be 8, 20. For the dog, it's 12, 20. And for the horse, it's 20, 50. Okay, so this is representing the data as ordered pairs. Okay, lots of times you're going to have a table of information. Typically the first column is your x and then the second column is your y. So we have the ordered pairs listed here, okay, from the table before, and we're going to talk about, well, what is the domain for this information that we are given here. Okay, so domain is right here the x values. Okay, those are our x values. So if we're talking about the example we have here, we list out the x values. So there's 12, 15, 8, 12, and 20. Here's the deal. Typically when you're talking about domain, you list it in order, okay, from smallest to largest, and you don't double list it. So my smallest number is 8, okay, and then there's two 12s, but I only write down one. Okay, if you write down more than one 12 on your next quiz, then I'll go ahead and take off points because you only need to write it once. Then there's 15 and 20. Okay, so that's my domain. The range then is your y values. And we will be talking about domain and range a lot, so you want to make sure you get this down right away. So we have 28, 20, 30, 20, and 50. And once again, we only write them one time. So my smallest one is 20. So I have 20. Then I would have, there's two 20s, so I only write it once. Then I have 30. So, nope, 28 first, right? 28, then 30, then 50. Okay. All right, so there is that. Domain and range can be represented as a mapping. Okay, so here is a mapping. If you look, we have the order pair 12 to 28. So here's my domain, and it maps to 28. Okay, I have the order pair 15. It maps to 30, and then 8 maps to 20. So this is an example of a mapping, just so you know what that will look like. Then the next thing that we need to look at is, how do we know if something is a function? Okay, there's what we call the vertical line test. It says if no vertical line intersects a graph in more than one point, then the graph represents a function. Okay, so I have two examples here. Okay, so to be a function or not, if you look, there is only one x value for every y value. If I did a vertical line, sorry, that's not a very good vertical line. Straight up and down is vertical, but if I did a line straight up and down, and I carried it through this graph, would it only touch one point at a time? Yeah, I'm only touching one point at a time. So this means, yes, it is a function. The next one, if I do my line, am I only touching one point at a time? No, I'm touching two. So this would say that it is not a function. So this would be a no. All right. If we're just looking at ordered pairs and we don't have a graph, we want to be able to determine if something is a function or not. So this can sometimes be tricky. But for instance, it's kind of hard to see the numbers on here. I think that this point roughly right here, we have 2, 2. Oh, that's a bad one to choose. Sorry, let me pick another one. That one's not going to be as easy to see. If I pick the point let's just say it's 4 and approximately 2.5. And if I have the point 4 and negative 2.5, notice, if my x values are exactly the same, then it is not a function, so it is not, okay? So, and if all my x values are different, then it is a function. So if I'm looking at ordered pairs, I want to be able to know if something is a function or not. I need to look at my x values. And if there is an x value that repeats, then it is not a function. So, to cover this question here for my example, I have 12, I have 15, I have 8. Those are all different. But then I go to 12 again. So would this one be a function? No, and that's because my x value repeats. Okay, and graphically, if I were to look at this, say this is 12, and then just for instance, this would be 1220, and let's say this is 1228. Would that pass my vertical line test? No, it would touch both functions at the same time. Okay. These are just more wording, so this is another way you could say your domain. Set of all x coordinates. Y is the set of all second coordinates. Okay. All right, so we're going to move on. So now we're going to go ahead and look at something graphically to decide, is it a function or not? So on your graphing calculator, go ahead and get that out. We are going to decide, is y equals 3x squared minus 5 a function? Okay. So in order to do this, everybody should get out your graphing calculator. Okay, and this is kind of the first step in figuring out how to use our calculator. So here it is. And I go to, so chances are you have a screen like this. So you hit the y equals, and then we're going to type it in. So we type 3, and then your x is below the mode. Okay, x, and then to go to the second, right here, on the left-hand side, minus 5. Okay, and we want to graph it to make sure that it looks like a function. So first thing I'm going to do is go to Zoom, Standard. That brings me back to my standard window. And by standard window, I mean I'm going from negative 10 to 10, negative 10 to 10. So graphically, is this a function? If I do my vertical line test, okay, will it only touch one point at a time? Yes, it will. So this one is a function. So maybe you want to just sketch it, this one. Is it a function? Yes. Okay, let's go ahead and look at the next one. We want to graph these two functions. And what it's saying is a square root. Didn't come out very well. Square root of all of this. Okay, so once again, we're going back to our calculator. And I'm going to hit y equals. And I'm going to hit clear because I don't want this function anymore. So now I want the square root. So to get the square root, notice how it's above my x squared. So second square root. And then I want 1 minus x squared. Okay, and that should all be underneath the square root sign. Hit enter. And now I want negative. Make sure you hit the negative button that's below the 3. Okay, otherwise it's a subtraction and we don't want that. So then we're going to do the same thing. 1 minus x squared. And I'm going to go ahead and hit graph. Graphically, that's what that looks like. It looks like a circle. So, would that one pass my vertical line test? Would it touch more than one point at a time? Yes, it would. So, since it will touch more than one point, we say no, it is not a function. And maybe we want to draw a y. Here it looks like a circle. Touching more than one point at a time. So, no, it is not a function. Okay. All right, let's move on to our next example. So, we have some ordered pairs. We want to find the domain and the range of each relation. Okay, then we need to decide if it's a function or not. So, domain, those are my x values. Remember, we do them from order smallest to greatest. So, I look, none of them repeat, and they're actually written in order for me, so that's nice. So, that is my domain. All right. And now moving on to my range, those are my y values. I have 0 and 1 and negative 2 and 2. So none of those repeat, but I got to write them in order. So negative 2, 0, 1, 2. Okay, that's my domain and range. Now I need to go ahead and decide, is this a function or not? So remember, to be a function, if we're looking at ordered pairs, none of the x value should repeat. Did any of my x values repeat? No, they did not. So yes, this is a function. Okay, so there's example 1. Example 2. This one's kind of nice. They gave us a graph for this one. So we have a bunch of ordered pairs here, and I want to write down the domain. Domain is my x values. So I'm just going to look from left to right to get them in order. So I have -4, -1, 0, 2, and 3. That's my domain. Got them all. And right away I should check, did any of my x values repeat? No, they didn't. So would that mean it is a function? Yes, it would be a function. So we can do that right away if you want, because it does. You do look at your domain to figure that out. The other way you could check is, if I do a vertical line test, does it ever touch more than one point at a time? No, it does not. So we know it's a function. And then last thing we need to do for this problem is list out our range. Okay, so in order, and I'm going to start, remember those are your y values, so range is y. So I'm going to look from bottom to top to put them in order. So -4, -3, -2, and there's 2 3's listed, which is okay. It still means it's a function, but I only write 3 one time. All right, and that is it for example 2. The next thing we're going to talk about is function notation. Okay, function notation is a relation. If a relation is a function, you can replace the y with f of x. Okay, so this is something you need to get used to seeing, because you see function notation fairly frequently when you go on to further math and in this class. So y really means f of x. So if I see an equation written y equals x squared plus 3, it means the same as if I write it as f of x equals x squared plus 3. Okay. What it is saying is that your independent variable is x. You plug in x and you get out y. Okay, so independent variable is usually the x variable depending on the domain. So I always say it's what you plug in for x, and your dependent is the y variable representing the range. Okay, so just some terminology there. So given, we have an example here, f of x equals x squared plus 2. Find f of -3. All right, so everybody see, if I rewrite this below here, f of -3. -3 is in the spot of the x. So when I solve this problem wherever there's an x, I write -3. So -3 squared, it's really -3 times -3, so 9 plus 2. So 9 plus 2 is 11. So f of -3 is equal to 11. That's a little function notation for us there. One thing I want to point out to go along with this is, who's my x value? I plugged in -3. And I got out 11. So it's really an ordered pair, -3, 11. And this is my independent variable. This is my dependent. So here's another example. Given g of x is equal to 3x minus x squared, we need to find the following. Okay. So A, we need to find g of 2. So I'm going to go ahead to find g of 2. Remember, 2 is taking the spot of x. So it's going to be 3, now there's an x, so I write 2 instead, minus 2 squared. And then I solve. It would be 3 times 2 is 6, minus 2 squared is 4. 6 minus 4 is 2. So when I plug in 2, I get out 2. So I really have the ordered pair 2, 2. But I can write, my final answer is g of 2 equals 2. The next thing I need to do is I want to do g of 3 times g of -1. So I need to figure out, well, what do I get when let's find g of 3 and let's figure out, well, what is g of -1? So g of 3 is equal to 3 times 3 minus 3 squared. So this would give me 9 minus 3 squared is 9, okay, which gives you 0. And then I find g of -1. I would have 3 times -1 minus -1 squared. This will give me -3 minus, well, -1 squared. -1 times -1 is a +1, so it's -1. Negative 3 minus 1 is negative 4. So if I plug those in, we have g of 3 equals 0 times g of negative 1, which equals negative 4. 0 times negative 4 is 0. So my answer for that one is 0. All right, and one last one, C. We need to find g of 3x. Okay, so this one looks a little more confusing because it has that x variable in it, but we're going to go ahead and just wherever there's an x, once again, plug in a 3x. Okay, so we have 3 times x, so it's 3 times 3x minus my 3x squared. 3 times 3 is 9x minus, now I have to square each part, 9x squared. Okay, so in this case, my answer is that g of 3x is equal to, and typically we write it in standard form, meaning I put the x squared first, so minus 9x squared plus 9x. Either answer, though, I would take. This way, or if you wrote it this way. They mean the same thing. Okay? All right. That is up to example 3. Now would be a good time if you have any questions, write them down, pause the video, take a little break, and then when you get back, we're going to talk about linear equations. Okay, hopefully you took that chance and took a little bit of a break. Now we are going to look at linear equations and linear functions. Linear equations have no other operation other than addition, subtraction, and multiplication of a variable by a constant. Okay. And a linear function has ordered pairs that satisfy a linear equation. And any linear equation can be written as y equals mx plus b. And earlier on the notes, we talked about how f of x and y mean the same thing. So you can write it either way. So this is slope-intercept form. They call it slope-intercept because m is your slope and b is your y-intercept. Okay. Also remember standard form. Standard form can be written as when you have your x and your y on one side and then you just have a constant or a number on the other side. Another thing to notice about to be linear, notice how my x, it's really x to the first power. If you have an x to the first power, that's what tells you that it's a linear equation. Okay. So let's go ahead and look at what we have over here. We want to talk about x-intercepts. Okay, you're going to be asked to find x-intercepts a lot. The way you always find an x-intercept is it's when your y equals 0. And the reason, x-intercept, here's my x-axis, so I want to know when does it hit there. Well, that's when your y value is equal to 0. This is the ordered pair here for 0. So it's when my y was 0. Okay, so it's when y equals 0 and it's when it crosses the x-axis. Crosses the x-axis. Okay. Then the y-intercept, guess how you always find that? Well, this is the ordered pair, 0, 4, so you always find it when x is equal to 0. And it's where it crosses the y-axis. Okay, that's the x and the y-intercept. All right, so we have some problems to talk about, okay, like example 4, and we want to decide, is this function linear, why or why not? Okay, in order to be linear, like I said, you have to have an x to the first power. Okay, well, does this have an x to the first power? Yes, it does. So is it linear? Yes, and the reason why would be because we have an x to the first. If I had written 3x squared, you would say no, because it's not an x to the first power. Next example, example 5. Is this one linear or not? It says check this one out on your graphing calculator. So if you don't know, let's get out our graphing calculator and try it out. So we go to our y equals. We clear out what we have in there from earlier. So clear and enter. And I'm going to go up to my first equation and type it in. Okay, we want 7 divided by x. And I hit graph. Okay, remember to be linear or you're a line. Does this look like a line? No, it does not. Okay, so is this one linear? No, it is not. Now we need to come up with a reason why it's not linear. So this is a no. And I'm going to tell you that this one can be, because the x is in the denominator, you can really rewrite this as 7x to the negative 1. So x is really not to the first power, it's to a negative 1 power. So it's because, x is in the denominator. X is not in the denominator on linear equations. Handwriting's a little sloppy there. So x is in denominator, that's why. And that also brings with that, it's addition, subtraction, and multiplication. There's no division. Okay, so that makes it not linear. All right, the next one, we're also going to check on our calculator. We have y equals x to the fourth minus 5. Chances are you can see it's an x to the fourth and not just an x, but let's go ahead and do it. So we would have x. Now to do to the fourth, here's a little caret. So to the fourth, and then you type 4. And if you have a calculator like mine, to get out of there, you have to arrow over. Now it'll get you out of the exponent. Minus 5. And then I'm going to go ahead and hit graph. Once again, does this one look linear? Does it look like it has a straight line? No, it does not. It looks like a parabola. So no, this is not linear. Why or why not? I would say because it has that x to the fourth. Okay. If you're not sure if something's linear, graph it on your calculator, and if it gives you a line, it's linear. If it doesn't, it's not. All right, so example 7, we have 2 examples to go here. So it says find the x-intercept and y-intercept of the graph of each equation, and then we actually want to graph it. All right, so let's put this one into standard form first. So remember, standard is when you have your x and your y's on one side. Okay, so let's move the 12 over. To move it over, I would subtract 12, so I have 3x minus 4y is equal to negative 12. Okay, we're finding our x-intercept. How do I always find x-intercept? Well, that is when y is equal to 0. So we're going to plug in 0 for y. So we have 3x minus 4 times 0 equals negative 12. 4 times 0 is 0. So I have 3x equals negative 12. So x is equal to negative 4 when I divide both sides by 3. So my x-intercept is the ordered pair, negative 4, 0. I can graph that on here. X-intercept, negative 4, 1, 2, 3, 4, 0. Now my y-intercept, remember that is when I always let x equal 0. So I plug in 0 for x. So I have 3 times 0 minus 4y equals negative 12. That's gone, that's 0. So I have negative 4y is equal to negative 12. So I divide both sides by negative 4 and I get y is equal to 3. So I have the ordered pair when x is 0 and y is 3. So right here, 2 points is enough to draw my line. I can see it. But I want to go ahead and use another way to check. Let's put this into slope-intercept form. Remember, slope-intercept is y equals mx plus b. Okay, so we're going to do that. So if I do that with this guy, I would subtract 3x to the other side. So I'd have negative 3x. Negative 3x minus 12. And then I would divide everything by negative 4. So I have y is equal to negative 3 divided by negative 3 is negative 4 will be positive 3/4 x. And then negative divided by negative will be plus 12 divided by 4 is 3. So I check, is my y-intercept 3? Yes. And is my slope 3 over 4? Okay, well I could check. I could go up 3 over 4, put me about here. Does that look like it's lining up? Yes. Or the other way I could go is down 3 to the left 4. And yeah, there it is. So there is, then obviously try and use a straight edge to draw your lines. But there you go. There is example 7 graphed. 2 ways you can do it. Find the x and the y-intercept, or you can put it into slope-intercept form. Okay. Example 8. Same type of deal. This one, though, is not in standard form. It's in slope-intercept form. It is in y equals mx plus b. So remember, b is your y-intercept. So I should know right off the bat which one is my y-intercept. It's negative 9. So it's the ordered pair 0, negative 9. Now I need to find my x-intercept. Excuse me. It's when y is equal to 0. So 0. is equal to 3x minus 9. So I would solve this, add 9. So 9 is equal to 3x, divide by 3. 9 divided by 3 is equal to x, so my x-intercept is the ordered pair 3, 0. So I have the ordered pair 0, negative 9 for my y-intercept. So this is negative 5, negative 6, 7, 8, 9, roughly here. And then I would have the ordered pair 3, 0. Okay, then I could check with my slope. My slope is 3. So that means I'm going up 3 over 1, up 3 over 1, up 3 over 1. So yeah, I am working out here. Maybe I should draw those on there. So there's my line. Sorry, it goes a little bit off my graph. I could keep going on here. Up 3 over 1. And so there is my line graph for example 8. All right, that's going to be it for this video. If you have any questions, please write them down. Otherwise, have a great day.